With your exam just few weeks away, there is no time to go through everything. Hi, I'm Terry. With over 25 years of teaching experience, I've created Express Notes to help you focus on the most important concept and question so you can revise efficiently. Today, we're covering chapter 3.1, system equation in 3 variable. Let's get started. System equation is divided into two parts. The first part, of course, is the equation in 3 variable. 3 variable means in this form, ax plus by plus cz equals to d. All right. So we can represent in the 3D diagram like this. Is your 3D, left, right, up, down, in, out, right? Okay, so solve the linear equation like this. There are actually two different ways of doing, but you don't have to do entirely one method. You can use elimination, you can use substitution. Sometimes one method is easier than another. All right, and you can use mixed method. It's fine. They don't say, oh, you must use one particular method. No, yeah, it's open. Okay. Now we go straight to example 1. I just go straight to this question. So for me, when I look at some equation, it has no, like this equation, no y, right? Equation 1 has no y. Equation 2 got y, and 3 got y. For me, I will get rid of y. Get rid of this y. Okay? To get rid of y, right, I prefer to use elimination. I just have to make sure they share the same coefficient. So the first one, the coefficient is 1. Second one, coefficient is -2. So we will take equation 2 multiplied by 2. So 3 times 2 is 6. Y times 2 is 2y. 2z times 2 is 4z. 7 times 2 is 14. This is equation number 4. Okay, I've got equation 3 and equation 4. What do? We add them together. Okay, so guys, 1x plus 6x, how many x? 7x. Minus 2y plus 2y, 0y. Minus 3z plus 4z, how many z? 1z. The result equals to 8 plus 14 is 22. This is equation number 5. You see, if you look at this equation 1 and equation 5, they share the same unknown x and y. Okay, guys, before you label equation 5, can I change my mind? Straight away make z as a subject. Isn't it easier? So you notice or you want to use purely elimination? You can use purely elimination, but I think in this case, if you use purely elimination, you have to take equation 5 times 2. Okay, guys, give me some feedback. Do you prefer substitution or elimination from here? Okay, substitution. If you want to use substitution, we make z as a subject. Z equals to 22 minus 7x. This is equation 5. We sub equation 5 inside equation 1. So your 2x plus 5, your z is 22 minus 7x equals to 11. 2x plus 110 minus 35x equals to 11. This is negative 33. Yeah? Okay. 2 minus 35, negative 33, 110. When you bring to the right hand side, this is 11 minus 110, negative 99. 99 divided by 33, x is 3. So once you got your x value, you need to find your y or your z. Maybe I sub inside equation 5 first. Find my z. My z is 22 minus 7 times 3. 7 times 3 is 21. 22 minus 21, z is 1. I sub inside equation number 2. You can sub inside equation 3 as well, but equation 2 is easier. I got my x already. X is 3. I plus with y. I got my z already. My z is 1. This is 7. So this is 9 plus 2, 11. My y is 7 minus 11, negative 4. Okay, what would you do? Call this equation 1, call this equation 2, call this equation 3. I prefer elimination over substitution. In the event that all 3 terms are given like this, right? All 3 has x, y, z. We look at the LCM. Which one has the smallest LCM? The first one, your LCM is 12, right? Second one, what's the LCM? 2, 5, and 1. My LCM is 10. Third one, what's the LCM? My LCM is 3. Okay. So the easiest one to get rid of would be z, right? Z has the smallest LCM. So we will take equation 3 minus equation 1 first. 3 minus 1. 4x minus 1x is 3x. 2y minus 2y is 3y. I mean 1y minus 2y. 1 plus 1 minus 2, 1 plus 2. Okay, 3z minus 3z disappeared. 10 minus 7, you get 3x plus y equals 1. Okay, now it looks like, can we use substitution? So like I said, you can use mixed method. Y equals to 1 minus x. Yep, equation number 4. Now, at the same time, right, you see, if you manage to get rid of z from the first and third equation, you still need to get rid of z from the second equation. So what I need is to make z have the same coefficient of 3. So I'm going to take equation number 2 multiplied by 3. So 3x times 3 is 9x. 5y times 3 is 15y. Minus z times 3, negative 3z. 4 times 3 is 12. This will be equation number 5. Okay. Can we take equation 1 plus 5? Why do I plus 1 plus 5? Because I will get rid of z. 1x plus 9x is 10x. Minus 2y plus 15y is 13y. Minus 3z plus, positive 3z plus negative 3z becomes 0. 7 plus 12 is 19. Equation number 6. We substitute equation 4 inside equation 5. So my y is 13. 1 minus x equals to 19. My 10x plus 13 minus 13x equals to 19. Right? 10x minus 13x, negative 3x. 19 minus 13 is 6. X is negative 2. Then find your y. Sub inside equation number 4. Your y is 1 minus 2. Y is 3. So you got your x, you got your y, you can find your z, right? Sub inside equation number 2. My x is minus 2. My y is 3. I find my z. So it's minus 6 plus 15. This is 9, right? The result is 4. Z is 5. Okay, by the way, there is a way to double check your answer. You don't know this. This is not a secret anymore. All of you know that this calculator can do it. In fact, the silver one can do the same. Silver one can do the same, but I think the majority of you are now using this calculator. So I'm going to show you this one. Menu. Go to number, after 9, go to the right. This is table. This is equation. Press this for equation. Go to simultaneous equation number 1. Number of unknown is 3. So you got the x, y, z, and constant. Like this one means 1. This one is 1. If they don't write any number in front, is all these are 1. So I'm going to type in here 1 equals minus 2 equals 3 equals 7 equals. Next, 3 equals 5 equals negative 1 equals 4 equals. Lastly, 4 equals 1 equals 3 equals 10 equals. There you go. My x is negative 2. My y is 3. My z is 5. Okay, not difficult. The next question, again, solve 3 unknown. Call this equation 1. Call this equation 2. Call this equation 3. Right? So what do? Which one can we get rid of? X, y, or z? Which one is easier? Okay, let's look at the LCM. This one, the LCM is 10. The second one was the LCM, 12, right? This one, 3, 5, 4, 60. So it's easier to get rid of x, right? Yeah, we want the smaller number. Smallest is your x. X has all the smallest coefficient. So guys, I'll take equation 2 multiplied by 2. Why times 2? Because I want to get 2x. Okay, so this is 2x minus 6y minus 10z equals 38. This will be my equation number 4. So what do? You plus or minus? Minus equation 1 minus equation 4. 2x minus 2x, 0. The 4y minus 6y is 10y. Minus 3z minus 10z, so it's plus 7z. 30 minus 38, negative 8. Equation number 5. Right, so I can't do anything with this. I don't know what to do. I'll leave it out. Guys, check out if I made any mistake. Now, next, I will take equation 2 times 5. Why times 5? I want to get 5x. So 1x times 5x times 5 is 5x. 3 times 5 is 15. 5 times 5 is 25. 19 times 5, 95, right? Equation number 6. This one, just more equation, yeah, longer. So we'll take equation number 3 minus equation 6. Your 5x minus 5x disappear. Minus 2y minus 15y. So it's 13y, minus a plus. 4z minus 25. 4z plus 25. 29. Then 5 minus 95. Negative 90. Oh man, this is very long. So, okay, it's up to you. You want to use substitution, can, but you're going to make one of them subject and involves fraction, right? If you want to use elimination, can, but again, elimination, we need to pick the one with the smallest LCM. Now, it looks like 10y and 13y is easier to get rid of it, right? So I'm going to use purely elimination here. Guys, if you want to make y as a subject or z as a subject, substitute also can. So we take equation 5 times 13. Y times 13? I want to get 131. 7 times 13 is 91. 8 times 13, negative 104. 104, if you can't do mentally, please use a calculator. Then I take equation number 6, I times 10. 13y times 10, 130y. 29 times 10, 290, right? 90 times 10, 900. Oh my, this is very big. Okay, sorry, this is not 90, this is 95. I wrote equation 6, supposed to be equation 7. I wrote wrongly, 7 times 10, 290, 900, equation number 9. So now what do? Subtract, right? You can use equation 8 minus 9 or 9 minus 8. Okay, I'm going to do 9 minus 8. Sorry, very big number. This is 199, right? This is negative 1,000. Or did minus plus, so it's not 1,000, it's a plus, so it's negative 796. Oh my, is that correct? Yeah, minus 900. Sorry, let me show you this. Minus 900 minus is a plus, plus 104, isn't it? 796, you divide by 199, very big number. Z is negative 4. Then you sub inside equation number, I think number 5. 10y plus 7 negative 4 equals negative 8. 10y minus 28 equals negative 8. 10y is 20, y is 2. You can sub back inside. I want to find x. I've got my y, I've got my z. I sub inside equation 2. My x is an unknown. My y is 2. My z is negative 4. The result is 19. So this is minus 6 plus 20. 14, right? My x is 19 minus 14. X is 5. Let's talk about possible solution. Now, sometimes you can have no solution or unlimited number of solution. Okay, now before I do this, let me explain. So when you solve this equation for the x, y, z, right? When you get rid of one unknown, let's say you get 2x plus 3y. Let me use black pen. Let's say you get 2x plus 3y equals to 9. This line is a slanting line. with a gradient of what? What's the gradient? Negative 2 over 3. Can I imagine? What's your y-intercept? Your y-intercept is 3. So this equation is 2x plus 3y equals 9. Then let's say I have another line. The second line is 2x plus 3y equals to 6. They are actually parallel, right? But what's your y-intercept? Your y-intercept is 2. Now we know two parallel lines, they never meet. They will not intersect, right? So in the event that you get like 2x plus 3y equals 9, first equation, and 2x plus 3y equals to second equation 6, right? So if you're going to solve this simultaneously, let's say you take 1 minus 2, what do you get? You get 2x minus 2x, 0. 3y minus 3y, 0. And 9 minus 6 is 3. So you get 0 equals 3, which is what we call it a false statement, right? So that means there is no solution. On the other hand, let me just rub this off. Now, let's say you go and solve these two equations. Solve, then you got, oh, my first equation and second equation, they are both the same. They both have the same value, 2x plus 3y equals 9. Then if you try to solve them by elimination, we take equation 1 minus 2 or 3 minus 4, you should get what? 0 equals 9 minus 9, 0. Which is a true solution. I mean, it's true. In this case means that both lines, they overlap each other. When they overlap each other, how many solutions do you have? We say unlimited number of solutions. Yeah, so you understand this? Whenever you solve this, right, you get 0 or equals 0. That means they all intersect at 3 points. You have a unlimited number of solution or infinite number of solution. If you get a false statement, like such as 2 equals 0, they have no solution. Okay, so typically this question will come out like a short, it's just a very short question. It's like 4 marks type, because they can't give you a long, if you have solution, usually it's longer, like 5-6 marks question, because the answer itself, the question will not tell you it's unlimited. But what I can say is this, usually a 4 marks question in exam, we have either unlimited or no solution. Why? Because if you want to solve, x itself is 1 mark, y itself another mark, z itself another marks. To form 3 equations, solve them simultaneously, you cannot do like 2-3 equations, get it. You need multiple new equation, like what I've shown you earlier, right? So many equations, up to 7 or 8 or even 9 equations. So those type of questions will have more marks, like 6 marks or possibly 7. Okay, now let's look at this example. This one, equation 1, equation 2, equation 3. What do? I say get rid of y. Y is the easiest, right? Take equation 1 plus equation 2. 1x plus 3x is 4x. Okay, the 2y minus 2y disappear. 4z plus 3z is 7z. 5 plus 7 is 12. This is equation 4. Then we need to get rid of this for y. We need to involve equation 3. So I take equation 1 times 2. If you want to take equation 2 times 2, also can. I take equation 1 times 2 here. So I got 2x plus 4y plus 8z equals to 10. This is equation number 5. So these two equations I subtract, or should I think add, we add them. So 3 plus 5. When you add up, you get 4x plus 7z, right? 2 plus 10, you get 12. Now notice what happened here. These two, they are basically the same equation. So when you get the same equation, when you take equation 4 minus equation 6, what do you get? 0 equals 0. 0 equals 0 means what? Unlimited, or we say infinite number of solution. Yeah, the difference is like, just now I show you x, y plane, right? This is x, this is y, this is x and z plane. So the z is here. So maybe the graph looks like this. Then the second graph is also a straight line. They also overlap like this, right? So both actually meet at unlimited number of points. So for example 5, we call this equation 1, call this equation 2, equation 3. Who should I get rid of? Z, right? Z, right? Z, the LCM is 6. So I take equation 1 times 2 first, because I want to get rid of this 2z. So 4x 6y, 2z equals to 8. Equation 4. 3 and 4, we add them up. Equation 3 plus 4, 9x minus 5y equals to 11. Equation 5. Then equation 1, I must times 3 because I want to get rid of this 3z. So when you times 3, you get 6x, 9y, 3z equals to 8. This will be equation 6. Should I plus or minus? We'll take equation 2 be plus with equation 6. So 3 plus 6, again, you get 9. 4 plus negative 9, negative 5y. And 2 plus, oh, this one is 12. Sorry, this is 12. Thank you. All right, then, correct? Then I take equation 2 plus 6. This is 14, right? Is it 14? This is equation number 7. Okay, now let's focus on these two equations. We can see that they have the same coefficient of x and y, but different number at the back. So when I take equation 7 minus 5, you can do 5 minus 7. You should get 0 equals to 3. In this case, it's a false statement. We say there is no solution. Yeah, the equation has no solution. So I have two word problem here. This is the first one. So you can form the equation and then solve the equation simultaneously. Let's start with example 6. Okay, so during a sale, Joshua bought X shirt, Y pairs of shorts, and Y Z pairs of pants. The price of a shirt is 60 ringgit. Pair of shorts is short pants is 40 ringgit. Long pants is 100. So he bought 10 items and paid a total of 620. So okay, I think the first equation is the total number of items that he bought. He bought X plus Y plus Z equals to 10. First equation. My second equation is the price. He paid a total of 620. So a shirt is 60 ringgit. Short is 40 ringgit. And long pants is 100 ringgit. Okay. The result must equal to 620. I noticed that this equation here, you can divide everything by 20. So 3x plus 2y plus 5z is now 31, right? Okay, my third equation is this. He bought, they say the number of shirt that he bought is one more than twice the number of long pants. Okay, shirt is X, right? Is one more than twice the number of long pants. Long pants is Z, yeah? So is 2Z plus 1 equals to your shirt. For example, your long pants may be 2. 2 times 2, 4. 4 plus 1, 5. Your shirt is 5. Okay, so since my third equation, X is already written as a subject, I think we can straight away sub equation 3 inside equation 1. So my X is 2Z plus 1 plus Y plus Z equals to 10. This is Y plus 3Z plus 1 equals 10. Up to you. I think I can straight away make Y as a subject. Y is 9 minus 3z. Call this equation 4. Okay, so I still need to solve equation 2 and 3, right? So I've involved 1 and 3. I haven't done 2 and 3 or 1 and 2. So maybe I sub equation 3 inside equation 2, right? Equation 3 put inside equation 2 is 3x is 2z plus 1 plus 2y plus 5z, the result is 31. 6z plus 3 plus 2y plus 5z equals to 31. 2y plus 11z equals 28. Equation number 5. Now what do? You sub equation 4 inside equation 5. Your y is 9 minus 3z plus 11z equals 28. 18 minus 6z plus 11z equals 28. 11 minus 6 is 5. 28 minus 18 is 10. Z is 2. I got my z, I got my x, I got my z, I'm going to find my x and y, right? Sub inside equation 3. My x is 2 times 2 plus 1. My x is 5. Then I sub inside equation number 4. My y is 9 minus 3 times 2. 9 minus 6, y is 3. For example number 7, you're going to form 2 equations and 3 equations actually and solve it simultaneously. Right, so here Roshan is training for a triathlon. So that means he has to do 3 different types of exercise. Number 1 is running. Number 2, cycling. Number 3, swimming, right? So the table shows the distance covered and the time taken for each training session. So he trains for a total of 12 sessions a week. So we know total, because he trained supposed to be X hours of running a week, Y hour of cycling, and Z hour of, or should I say this is session? The number of session, okay? Number of session, because you are finding the number of session that he undertakes for running, cycling, and swimming in a week. So X is number of session that he spent running, Y is number of session he spent cycling, Z is swimming. So we know total number of session that he did in a week is X plus Y plus Z equals to 12. Let's call this equation number 1. Okay, second one is the distance that the distance covered for running, right? If each session he runs 5 kilometers, so what is the distance he runs if he conducted like 10 sessions, so it's 5 times 10. If he conducted 2 sessions, 5 times 2. If he ran like in 3 sessions, X session is 5 times X. Cycling is Y, so it's 10 times Y. Yeah, right? 10 kilometers for cycling. Swimming 2 kilometers, 2 times Z. Total 76 kilometers. This is in a week. All right. Now, how about the time taken for each session? Running, half an hour, 30 minutes for running. So it's 30 times X. Cycling, also 30 times Y. Swimming is longer, 40 times Z. Total time in minutes, 390. So can we just divide everybody by 10? Just make the number smaller, 3X, 3Y, 4Z equals 39. Call this equation 3. So I'm going to solve this simultaneously. So the thing is, what should I get rid of? If you look at this, right, maybe it's best we get rid of Z. Because I have 1Z, 2Z, 4Z, the LCM is 4. If I use 1, 5, 3 for X, the LCM is 15. If I use Y, 1, 10, 3, the LCM will be 30. So let's get rid of Z. But let's take equation 1 multiply by, let's start with equation 1, multiply by 2. So I get 2X, 2Y, 2Z equals to 24. That's equation 4. So now let's focus on equation number 2 and 4. We'll take equation 2 minus equation 4. So 5X minus 2X is 3X. 10Y minus 2Y is 8Y. 2Z minus 2Z disappears. 76 minus 24, that will be 52. That will be my equation number 5. Now, at the same time, I need to get rid of Y from the third equation here. This is 4Z, this is 1Z. So I will take equation 1, multiply by 4. I'll get 4X, 4Y, 4Z. Answer is 48. Call this equation number 6. Now, remember, I want to get rid of Z. So let's take equation 6 minus equation 3. So 4X minus 3X is 1X. 4Y minus 3Y is 1Y. 48 minus 39 is 9, right? Now, here we can do a bit of mixed method. Up to you. You can use substitution if you want. You can make Y as a subject. Or you can just take this equation, multiply by 3 to get rid of X from equation number 5. Okay, but I think maybe I just make Y as a subject. Or X was so okay. Up to you. 9 minus X. Let's call this equation 7. We sub equation 7 inside equation 5. Your X, 3X plus 8Y. Y is 9 minus X. The result is 52. So 3X plus 72 minus 8X equals to 52. Negative 5X equals to negative 20. X is 4. Okay. Now that you got X value, right? So let's sub inside equation number 7 to find your Y. My Y is 9 minus 4 equals to 5. and sub inside equation 1 to find my z. So 4 plus 5 plus z is 12. Z should be what? 12 minus 9, 3. So that means what is x? The number of hours number of sessions, for running. Y is number of session for cycling, and Z is number of session for swimming. If this video helped you, you can get my AdMaths book from Shopee or Lazada, or by searching Taliti. For full step-by-step learning, check out my e-course or join my classes at Pusat Tuition Taliti. Remember to like, subscribe, and share. See you in the next video.